Hello students, let us solve this Irodov problem number 1.79. What is the minimum acceleration? Okay, so this is the first point. We have to calculate minimum acceleration, not acceleration. With which bar A, minimum acceleration of what? Bar A should be shifted horizontally to keep bodies 1 and 2 stationary relative to the bar. So, body 1 and body 2 are at rest, but not with respect to ground, but with respect to block A. So, this is the given data. The masses of the bodies are equal. So, it is given that mass of block 1 and mass of block 2 are equal. So, let me call it M. And the coefficient of friction between the bar and the bodies, not bodies. So, coefficient of friction is K. The masses of pulley and the thread are negligible and the friction in the pulley is absent. So, these are the given data and there is a figure. This is the figure. The bigger block A is on the ground. A block 1 and block 2 is connected by a massless thread passing over a massless pulley. Now, we have to calculate at what acceleration the body A should move in horizontal direction so that block 1 and block 2 are at rest with respect to A. So, both bodies 1 and 2 are at rest, okay, but with respect to A, so I draw the free body diagram and write equation with respect to A. So, my reference frame is A, which is a non-inertial reference frame because A have acceleration. Now, first I draw the free body diagram of block 1. How to do that? For block 1, mg will act in downward direction, yes. Normal will act in upward direction, n1. Tension will act in plus x direction, yes. Tension will act in plus x direction and a pseudo force will act in minus x direction. Why? The acceleration of observer is in plus x direction. So, direction of pseudo force should be in minus x direction. What is the magnitude of direction of pseudo force? Mass of object into acceleration of observer. So, these are the forces. Now, there is a friction force. Now, there are two cases. Let me say this block try to move in plus x direction. So, the friction force will act in minus x direction. So, this is one possibility. There is another possibility when all these forces are acting, mg will act, normal n1 will act, tension will act, pseudo force will act, and this block try to move in minus x direction. So, friction force will act in plus x direction. So, according to this equation, MA should be equal to T minus F, and according to this diagram, MA should be equal to T plus F. So, this is the sum of two forces. So, this acceleration have higher number and these are the difference of two forces. So, this acceleration has a lower number and we have to calculate the minimum value. So, minimum A comes out when this situation occur. So, we don't have to do this, we don't have to do calculation according to this situation. So, my situation is this. Now, so the first equation is MA equal to T minus F and also N1 should be equal to mg. Now, for minimum A, the friction should be maximum. So, MA minimum should be equal to T minus K N1. So M into A minimum should be equal to T minus K M G. So this is the first equation. Now let me draw the free body diagram of second object. So for second object, mg will act in downward direction. Yes. Pseudo force will act in minus x direction. And this is the contact surface. So normal will act in plus x direction. N2. Tension will act in upward direction. Now see this situation. If friction is acting in minus x direction, it means this block try to move in plus x direction. So this block try to move in plus x direction. So this block 2 try to move in downward direction. So friction on block 2 will act in upward direction. Now this block is also at rest. So N2 should be equal to M into A, and F plus T should be equal to mg. Now the value of this force, friction force, at a maximum situation is K into N2 plus T should be equal to mg. K, value of N2 is ma, so m into A plus T should be equal to mg. From this equation I can write that T should be equal to mg minus kma. So this is my second equation. Now from this equation and this, and I already know that at the minimum situation I can write A as am. Now put the value of t in this equation and I can get the value of minimum acceleration. So how to do that? The equation is m into am equal to t. This is the value of t, mg minus k m minimum acceleration minus k m g. M should be cancelled out at each term. Am should go in left side. So am plus kam equal to g minus kg. So minimum acceleration should be come out. One minus k divided by 1 plus k into g. So this is the value of minimum acceleration of block A, so that body 1 and body 2 are at rest with respect to block A. So this is the final answer.